One.
Turn the sound off for one thing. It's quickly go through the notes I just wrote with the other class today about graphs. So you guys should have written some notes as you went through yesterday, but I'm just going to show you what's on the OneNote so that you understand it. I'll do this very quickly and then we're going to move on. So what I talked about with the other group was categorical data. So we have two types of data, categorical and numerical, however you pronounce it, okay? Categorical data, you can use a pie chart graph and you're expected to be able to look at a pie graph, but you don't have to draw one. But a bar chart you are going to have to draw, okay? A bar chart will always have frequency down the side and you can use that big curly F. That's fine. You don't have to write frequency. You can just write a curly F for anything. And a scale starting at 0, okay? It then has the categories down the bottom. You need to have a space between them. Just as a reminder, anytime you're graphing, you should be using a ruler and a pencil, okay? And so that way you're going to get, if you make a mistake, you can change it, right? It's very important to use a ruler and pencil. When I teach middle school maths, I actually take marks off if you don't use a ruler and a pencil, right? In senior school maths, if you don't use a ruler in the test, you can lose marks as well because it's not accurate enough anymore. So you must have a ruler. It's also just for you. So if you make a mistake in a pen and then you make another mistake, it's really hard when you're like, it's the pink pen which is correct, okay? I can't work it out, I can't mark it. But also, the whole point of graphs is for us to be able to look at patterns and analyse it. And if you've got heaps and heaps of writing and all different coloured pens everywhere, you can't actually analyse it properly and you can't find out that information, all right? So just to be aware, you can also break the scale. I actually break the scale on most graphs, but you need to be aware of what it looks like. So breaking the scale is like either that sort of like zigzag or just two dashes, but there's certain rules, okay? So if you're going to break the scale, the smallest frequency must be above the break, okay? So the smallest number you're graphing must be above the break, and you can't break it more than once on each axis. All right, so for example, see here on this, why do you think I can't break it there at between the 200 and the 1,000? It's because it's actually, the whole point of graphs is for us to actually be able to see what the relationship is between the different categories. If you break it in the middle, that looks like the two columns are like about double each other, or a bit more than double, when actually it's like more than 5,000. Just put it on silent. Okay, it's actually like 5 times more. And so you can't actually see that difference as you go. Why do you think we do break the scale sometimes? Because the numbers at the start are too high. So if I just show you the example I did with the other class, sorry, these are the notes from my last year's notes. The example I did with the other class was if you had like the frequency of 1,001, 1,005, 1,010, if you had a bar chart, it's going to look something like that. And you're not actually going to be able to see the difference between them because you're going to have to include all the 1,000 and the difference is very minuscule. However, if you break the scale on that and you break it at 0, go to 1,000, you can see the difference between them and you're aware that they're all above 1,000. Can you guys see the difference between that? So that's the reason why you break the scale. Pardon? Yeah, so you can actually see it better, okay? You can see the patterns better. The other one we did was here, similarly, where you break it in the middle. It looks like it's only double, but actually it's like 15 times bigger, okay? So that's why you don't break it. You can't break a scale right in the middle and you can't break it twice on the same thing. Everyone okay with that? All right, so then we then looked at numerical data. Discrete data we do with dot plots, okay? Each dot represents a person or a piece of data. So we don't have to have a scale down the left-hand side. Why don't we have to have a scale down the left-hand side? Because the dots are that scale, okay? So the dots show you the frequency. Now, down the bottom, we do have to have a scale. Notice that I've broken the scale because all the numbers were above 100. So I didn't want to have to go all the way to 100 and then so on. So instead I broke the scale, started 100, went to 104. How many people were surveyed in this? 11. So every dot is a person. It's a bit like, you know, that piece of paper I gave you with all your marks? And there's like box and whisker plots down the bottom with each assessment, but across the top, I was like, that dot is you, okay? That's a dot plot. There was a dot for every student who did apps and you could work out where you sat amongst them. Okay, so we do use these sort of thing in like real life. or maybe maths teachers too. All right, so then we looked at histograms. Actually, I'm gonna grab the notes. I'll change these notes over because I think these are better. I've improved over the years. All right, so we then look at histograms. Histograms are, again, for numerical data. There's no spaces between the columns, but there must be a column with space at the start and at the end. Often we break the scale to make these spaces, and all columns must be the same width. So we need to remember that. Sorry, I'm in the wrong. That's not the better one. That's the exact same one. This is the better one. Okay, so it still says the same thing. It's okay. So if we look at some different graphs with this one, sorry, I'm stuck here because my computer's running out of batteries last week. With this one, see how we've got frequency 3, 5, 2. We've got 5, 6, and 7. Now, if I was measuring, I said that for this, I was measuring the length of my index finger, and the length of my index finger was 6.7 centimetres. Okay, where would it go? Which frequency would be increased? If it was 6.7, it would go into the 7 because we would round it, yeah? Because we're rounding to whole numbers. So, therefore, we need to remember where most people go wrong with these sorts of graphs is that they actually draw this they do a scale like this to start with, and then they draw it 3, 5, 2, and then they draw it like this. What's the problem with this? It's not right. Why isn't it right? Yeah, well, if we just said 6.7 goes into the 7 column, right? But 6.7 on this scale is here, and it's in this column, right? So this is wrong. This isn't right, okay? Because this is saying that all the numbers between 6, with a 6 at the start of it, pretty much from 6 to 6.99999 are in here, okay? And that's not right. What it actually is that all the numbers, but here, this is 6. This is from 5.5 to 6.499999. And this one's actually 6.5 to 7.499999, and so on. Does that make sense? If that's a 6 in the middle, sorry, I think 5 should be in the middle, shouldn't it? Does that make? So therefore, if I put the 5 here instead, that's the middle point. It's on either side of that is where we're rounding to. Now, this makes it much easier for us to draw a histogram because you don't have to worry about the scale so much. As long as your columns are the same width and you put what's called the midpoint in the middle, you're still correct. Okay, so you don't actually have to have it along a scale along the bottom. Is everyone okay with that? So just remember, if your table has like single-digit unit numbers, you need to put that in the middle of the column. Each column needs to be in the middle. And that's where most people go wrong with histograms. Now, the other problem is a lot of time you end up with grouped data instead. Okay, so we have grouped data like 0 to 9, 10 to 19. Now, my question for you is, where does 9.4 go? 0 to 9. And where does 9.7 go? In 10 to 19. So this table is actually going from 0 to 9.5. Really? That's really where the cutoff is. And so when you draw, if you draw it with a scale along the bottom, you need to make sure that that line doesn't cut off at 10. It actually cuts in at 9.5. And this one would be at 19.5. So you need to be really aware of that. What you notice here is this actually is at negative 0.5 because the columns have to be the same width. That's really hard, but you can do it, but you just need to be aware of it. Instead, what we can use is what's called the midpoint. So if I find the middle point between 0 and 9, and 10 and 19 and 20 and 29, you'll notice it's 4.5, 14.5 and 24.5. What I can do instead is just put the dashes in the middle of the columns and write those midpoints in. And that makes it a lot easier for us to be able to draw our histogram. Can you see that? So either way is correct. If you want to do it along the scale, as long as you remember not to do the line to 10, You got to do it in between. Either way is fine. The only time a histogram is on a full number is when you get something like this, where it says x is greater than 0, greater than or equal to 0, and less than 10, and then 10 greater than or equal to 10 and less than 20. So if we were, again, we're measuring whatever, handspan something, and I said my handspan is 10 centimetres, which row would it be in, the top one or the bottom one? It would be in the bottom one because it says equal to or greater than. Well, if my handspan was 9.9, where would it be? The top one, because it's less than 10. And so for that one, the lines would be exactly at 0 and 10 and 20. So you need to see the difference between them. All right, and that's pretty much about those sort of doing those graphs as we move through. And you should have done some of those questions yesterday. Is everyone okay with that? Yeah? All right, so we're going to move on today to measures of centre. So could you write that as your title? I'm just going to copy that page of notes into your OneNote rather than the last year's ones because I think those ones are better. So measures of centre, we're into chapter 2.